All right, guys, this is going to be rough because I don't remember like anything. This is the semester review practice test. And there's 40 questions. Ouch. Okay, here's number 1. In the graph of the piecewise function f of x is equal to, I think that's set of, I don't remember, 2x if x is greater than or equal to 1, and negative 1/4 x minus 3 if x is less than 0. Which piece would have an open endpoint? I had to go back and watch like my own stinking horrible lessons to try to remember this stuff. So it has to do with these greater than, less than signs over here, okay? The circles get filled in, the endpoints get filled in when it has the equals sign. It does not get filled in, it's an open endpoint when it does not have it. So it's this chunk that's going to have an open endpoint. So your answer would be this one right here. Okay? Here's number 2. Choose the function that matches the graph. Okay? So we have to look at this and determine what it's telling us. Let's look at this bottom one first. We know that when x equals 3, 3 is not going to be included. Okay? So we're going to have just a less than sign. Okay? So x is less than 3. Okay? There's no equal. We also know that when it is 3, when 3 is included, it's going to be greater than 3. So x is greater than or equal to 3. Okay? So it has to be one of these two. Now let's look at these first numbers. We have a 1 and a 3 and a 3 and a 1. So these must be the y values. So if x is less than 3 given 1, that ties together. And x is greater than 3 given 3. So it has to be this one because x being less than 3 is tied to y equals 1. So this has to be your answer. Okay? Here's number 3. In the graph of the equation y equals x minus 12 squared plus 31, what is the vertex point? Okay, there's 2 ways you can solve this. You can go to GeoGebra and enter this equation in and then graph it and you'll be able to see your vertex point. But this is already written in the vertex formula for a quadratic equation, which is f of x is equal to a times x minus, this is h, this number, squared, plus k, where h and k are your vertex point, and h relates to x, k equals y, relates to y. So your point is negative 1231. So this would be your answer for number 3. This is for which response is the correct way to write the equation in vertex form for the function of the graph. Okay? So we're going to look at this. We need to figure out what the vertex is first. So the vertex is here at x is equal to 5 and y is equal to negative 3. So we know that our vertex is 5 and negative 3. Okay. We know that the vertex formula for this is going to be y is equal to a times x minus h, h in this case is 5, squared, plus k, in this case k is negative 3. So this plus is going to become just negative 3. It's just going to be subtract 3. Okay, so we have this much information. Now we can find out what a is, but there's no need to because every single answer is 2. So let's just find x minus 5. So this one's out and this one's out. Here's x minus 5 squared, and then it's going to be plus a negative 3 becomes minus 3. So it has to be that one. Okay, there's your number 4. Here is 5. Graph the quadratic y equals 3x squared minus 3, and what is the vertex of the quadratic? So this one is written in standard form, so we can't just pick the vertex h and k out of it. We need to actually graph it. We're going to go to GeoGebra to do that. All right, we're going to start our calculator over on GeoGebra, and we want just algebra, and we're going to input our formula, which is y is equal to positive 3x squared minus 3, and it went and graphed it for us. So we need to find the vertex. The vertex is the turning point of the parabola, and it can be either a low point or a high point. For this case, it's a low point. And our vertex is right here at x is equal to 0 and y is equal to -3. So your answer is right here, 0, -3. This is number 6. We want to write the equation of this graph of the quadratic in standard form. So we already know how to do part of this, but this time we are going to have to figure out what a means. So the first thing we need to do is figure out what the vertex form of the quadratic is. I know it says standard, but we're going to start with vertex because we can see what the vertex here is really easily. So we know our vertex here is 3 and -6, so I'm going to go ahead and write that down. Our vertex is 3 and -6. And vertex formula of a quadratic is y is equal to a times x minus h, which in this case is 3, squared, okay, plus k, which in this case is -6, okay. Now, in order to solve for a, we just need to find another clear point on here where the line crosses exactly at a cross point on the graph, and substitute those x and y values in here, and that will leave a as the only variable. So you can see it crosses really nice and neat there at 2 and -2. So that's going to be our, 2 and -2. That's going to be our second point that we're going to use. You could use any point where it crosses neatly. That's just the one I picked. So here our y value is going to be -2 is equal to a times x, in this case is +2, minus 3 squared plus a -6, okay? Now we're just going to go through PEMDAS and use our order of operations to solve this for a. So -2 is going to stay over here, okay? Parentheses is first in PEMDAS, so 2 minus 3 is a -1 squared, and plus a -6 becomes just subtract 6. -1 times -1 becomes a +1, so this is just going to be 1a. So -2 becomes just a. We don't need to write the 1. Minus 6. We're going to add 6 to both sides to get a by itself. And that's going to leave us with a is equal to, add that, 4. Okay, so now we know a is equal to 4. We have h, we have k, and we have a. I'm going to erase all of this so I have room to work. And what we need to do is take our vertex form and we're going to translate it into standard form because that's what the problem wants us to do. So our vertex form is f of x is equal to a, which is 4, times x minus h, which is 3, squared, plus k, which is -6. Okay, let's get rid of this because I don't need this information anymore. All right, so let's go ahead and write this in our normal. They're changing out f of x for y, so I'll go ahead and do that. So y is equal to 4 times. Now this squared gets written as x minus 3 times x minus 3, and we still have our -6 over here. PEMDAS says we need to do the parentheses first, so we're still going to have y equals 4 times, we have x times x, which becomes x squared. Okay, let's see if I can fix that. And then we have x times -3, so that becomes -3x. Then we have -3 times x, which becomes -3x. And then we have -3 times -3, which becomes +9. And we can close that parenthesis and throw on our -6. Now we need to combine like terms. So we have y equals 4 times x squared minus 3x, and minus 3x becomes -6x plus 9. Close the parenthesis, and we still have -6. Okay. Now we need to do this parenthesis. We can't be doing these terms yet. We need to distribute this 4 out. So now we have y equals 4x squared minus 6 times 4 is 24x plus 4 times 9 is 36 minus 6. Now we can combine these like terms, and that's going to leave us with y equals 4x squared minus 24x plus 30, which is right here. So there is your answer. Let's look at number 7. Graph the function, complete the ordered pairs for the x values of 0, 1, 2, and 3 by finding the y values. We don't have a function. I'm going to go back and see if I can find the function. All right, I found our formula. So let's go ahead and clear all. And we're going to put in our new function, which is y is equal to negative 2. Why is it not typing? Come on. Come on. Come on. Come on. Don't do this to me. Oh, it is. Okay, negative 2 times 8 raised to the power of x. All right? Graph that for me. And then I'll zoom out here so we can see this. Okay? And it wants to know complete the ordered pairs for the x values of 0. So at 0, x is equal to 0, y is equal to, it looks like 2. Yeah, negative 2. So 0, negative 2. Hey, look, we have our answer already. It has to be here. When x equals 1, we're at, they're saying negative 16. Let's look. Let's look. Let's look. Let's look. Let's look. Let's look. Oh, they disagree. They say it's 1 and negative 12 or something. I guess it doesn't really matter because we know it's 0 and negative 2. Oh, you know what we can do? I know what we can do. We can create a table. It taught us how to do this. So let's come here and let's go settings, maybe? Nope, that's not it. Okay, let's go. We're on algebra. Let's go table of values. Ha 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 ha. And we're going to start at the x value of 0 because that's what it tells us to. And our end value of x is going to be 3 because we want 1, 2, 3. There we go. Look, it says negative 2, 1, negative 16, 2, negative 128, and 3, negative 1024. So it's this one right here. Remember, these will be shuffled on yours. It might not be the third answer on yours. Okay. Given the graph of the exponential equation, which option is the correct exponential equation of the graph? Okay guys, this one is nightmarishly hard, and Dad Bob is ripping out a tile floor, so I apologize for the noise in the background. So I'm going to show you the way I would solve this. Okay, I never even figured out how to solve this in the lesson, so the chances of me figuring it out now are like non-existent. So what we're going to do is work smarter, not harder. It gives us all these formulas, so let's go ahead and graph them and see which one looks like that, because that is also a correct way to solve this. So let's go y. I gotta scoot this over. Y is equal to 6 times, it wants 1/2, but all of my tools disappeared, so we'll go 0.5. How's that for you? Raised to the power of I need my tools. Raised to the power of I need my tools. Do you like that? Raised to the power of I need my tools. Is it? Thank you. Raised to the power of x. Okay. Let's fix this now and see what we can see. Okay. So it should cross at 1 and 6. It doesn't show us crossing there, so it's not this one. This one is out. Let's try the next one. We've got 0.5 times 12 raised to the power of x. Let's graph that one. Yeah, that doesn't look right, so that's not it. Let's try the next one. Let's try 12 times 2 raised to the power of x. That's not right either, so hopefully it's this last one. Let's go 12 times 0.5 raised to the power of x. And look at that. We see we have a point at 1, 6. Here's 1 and 6. And we have another one at 2 and 3, so it's this last one. There you go, guys. That's how to work smarter and not harder when the book doesn't teach you how to do this stuff correctly. All right, here comes another GeoGebra one. It says graph the function blah and determine its endpoints. So let's go ahead and clear all. Oh, I didn't want to save it. That's dumb. Why would I ever want to save any of this garbage? I never want to do this ever, ever, ever again. Okay, so we've got y. No, come on. Y is equal to, we need the square root symbol, x minus 3. And if you just push your right arrow key, it will get you out from underneath that square root sign. Okay, there we go. Now let's zoom out and look. Oh, look at this. It does have an endpoint. That makes me happy because I was like, why would it have an endpoint? It does. It may only have one. Okay, so let's zoom in and look. And it looks like its endpoint is going to be at 3, 1. So there's your answer right there. 3, 1. Okay. Graph the cube root function blah. Select the set of ordered pairs in which all points lie on the graph of the function. So clear all. Let's come back to make sure it's on algebra and an input. Put y equals negative square root sign. Now I hope it will let me do a cube root because I'm not seeing that as an option. Well, crud. Cube root. Ha 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 ha. It's right there. Why can't I do it? CBRT of x. Is that what I need? Oh! Okay. Don't random click like I did. Don't have an aneurysm over it. Like, trust GeoGebra to actually be doing what you want it to do. But I got my cube root. Now, if you ask me to do it again, I'm going to have to go back and watch the video again. But there's our cube root. X minus 2, because I have no idea how I just did that. Minus, no. I said go out, minus 6. Okay. Now let's zoom out so we can see this. We need to see what points are on here. Let's start with the first one. Do we have a negative 6 and a negative 8? Nope, that one's gone. Do we have a 1 and a 7? Nope. Do we have 1 and negative 5? Yup. Do we have 2 and negative 6? Yup. Do we have 10 and negative 8? Yup. So it's this one right here. Let's double check the last one. We have negative 3, negative 5. Nope. Okay, so it's number 3 on mine. Okay. Graph and compare those two functions. What point do both functions share? Clear all. Discard. Let's graph our first function. We've got f of x is equal to x plus 2 squared. There's our first one, and now we need g of x. I don't know if it will let me do g of x. It tends to have issues with different letters. We have a fraction. Ah! Okay, go away. I didn't want this. Delete. Don't fat finger it. Let's go away. G of x. Actually, let's just delete this and start over. Okay, let's try. G of x is equal to, we need our fraction, and I'm not going to just slam into the keyboard this time. 1/2 x, not s, x plus 1. And we're going to take that to the cube root. Boop. Okay, now we have both of our graphs. What we need to know is what point do both functions share? And it's right here at negative 2, 0. Both functions have the same x-intercept at negative 2, 0. That's your correct answer. Calculate the average rate of change over the interval negative 3, 5 given the function blah. Okay, so both of these coordinates right here, the negative 3 and the 5, are both x coordinates. And we're trying to figure out the rate of change between when x is negative 3 and x is negative 5. So first we need to figure out what the y coordinates are for each of these points. So what we're going to do is we're going to take our x coordinates and we're going to plug it into this formula to solve for y. Remember, f of x can be interchangeably used with y. So we're going to say y is equal to 2. Our first x value is negative 3 squared minus 6. PEMDAS says we do parentheses first, so we have y equals to negative 3 times negative 3 becomes positive 9 minus 6, which then gives us y is equal to 18 minus 6, which means y is equal to 12. So our first coordinate pair is negative 3 and 12. Okay? And when we get to our formula, this will be a and b. Okay? Let's go ahead and that's not actually not a and b. Ignore that. Negative. It's hard to do this when you know somebody's doing demolition in the background. Okay, let's do the next one. So our next x value is 5, so we have y is equal to 2 times 5 squared minus 6, which gives us y is equal to, parentheses first, 5 squared is 25 minus 6. 2 times 25 gives us 50 minus 6. So y is equal to 44. So our second coordinate pair is going to be 5, 44. Okay, now that we have this information, we can take our formula for the average rate of change, which is f of b minus f of a, which is y coordinates, remember, divided by b minus a. So f of b, which is our y coordinate, is going to be 44 minus f of a, so this is b, this is a, minus 12, divided by our x coordinate, which is b, 5, minus a, which is negative 3, which becomes a positive 3. So 44 minus 12 is going to be 32 divided by 8, and I am so bad. I don't know what that is. 32 divided by 8 is 4. Okay, I thought it was 4, but I don't know for sure. So our average rate of change is 4, which is right there. Here's number 13, and it blurred all this, and it didn't load this, but it says, which of the following tables shows the correct order of combinations to transform f of x into x squared? F of x equals x squared into f of 2x plus 2 plus 9. Okay, guys, this one is a doozy. There has to be a typo in here, which is really frustrating, but this is all I have on the preview. Hopefully when you take the actual test you have more information than this, but there should be an equal sign here and then more. Okay, basically when you're doing transformations, our f of x here is being transformed into this, and we need to figure out the steps that you need to take to get from just plain f of x, which is a standard parent function, into this one. Okay, so our parent function is f of x is equal to x squared. Okay, this is going to be our new f of x, and you need to use PEMDAS, order of operations, to figure out how we're going from f of x to f of 2x plus 2 plus 9. Okay, so first let's look and see what happened to the x here. First we multiplied the x by 2. Okay, parentheses come first, then exponents, then multiplication and division. So we've got parentheses that were already in. There are no exponents, so we need multiplication and division next. So we need to multiply this x by 2. Okay, so step 1 is not going to be x squared. Step 1 is not going to be x plus 2. Step 1 is going to be 2x, so we already know it's going to be this one. Okay, next we still need to do the parentheses, so we're going to add 2. That jives. Okay, now I'm guessing it's because we have this x squared out here that they're doing this squared next. Okay, even though we're missing information here, so that still jives, and then we need to add 9. So this one is the most logical correct answer, even though we have a messed up problem. Here's number 14. Which of the following correctly identifies the transformations undergone from f of x equals the absolute value of x to, this is how it should look. We should have all of this information. F of negative x minus 3 equals the absolute value of negative x minus 3. So we're focusing here. How did f of x get to this negative f of x to negative 3. Okay, so the first thing that happens is parentheses. We have to look at that. So the x became negative, okay, and we're going to have to determine what that means. So the x became negative, and then we subtracted 3. Okay, and the absolute value came down, and all of this doesn't matter. So we need to figure out it means when what happens in the parentheses becomes negative, and then when what happens outside the parentheses is a minus 3. Okay, this is from my lesson Multiple Transformations. It tells us right here that when we go to y equals f of negative x, which is exactly what we did, it's a reflection across the y-axis. So it's going from up above the from the left of the right axis to the right, or from the right to the left. It's flipping side to side. So we had a horizontal reflection for our negative x. Okay. This is from that same lesson. Now you can see when you have something that's outside of f of x and it's a minus, so this minus k, it means it's going to move to the left. So we had a horizontal translation. So first we had a horizontal reflection, then we had a horizontal translation. So reflected across, not the x-axis, reflected across the y-axis, and translated horizontally to the left is what we're looking for. We did have a y reflection, but we also had another thing, and it was not translated down. It was translated left. So there's your correct answer for number 14. Oh my goodness, I don't have this lined up. I'm sorry. Okay, the original function y equals 2x squared has been transformed to create the function on the graph. Which key feature helps to illustrate the transformation? Now we know that the parent function for this is going to be y equals x squared. And that's just going to be a regular old parabola that touches that middle point, that 0, 0. So it would look something like this, okay? But because we have 2x squared, we know that something happened to it. Well, it's no longer touching right here, so we know that it's been translated. It's been moved somehow. So it says the y-intercept is located at 0, negative 4. That is correct. Thus, it has been translated down 4 units. This could be correct. The point 24 shows a reflection over the y-axis. Okay, so this is the y-axis. If we're reflecting, you're not going to be able to tell with a parabola because they're a mirror image. So this is irrelevant. The y-intercept is located at 0, negative 4. Thus, it has been reflected over the x-axis. If a parabola is reflecting, it's going to go from this to this. And that has to do with positive and negative before the x squared. So that's not what we're dealing with here, okay? The point 24 shows the graph has been stretched, okay? Stretching means it gets fatter or it gets skinnier. That's a possibility, but I mean the obvious answer here is that it's been moved down. So this is going to be your correct answer. It may have been stretched. I can't tell without looking at a parent graph, but we can guarantee that this happened. So this is going to be your correct answer. Here's number 16. The graph represents the quadratic function y equals 2x squared minus 8x plus 3. If this function is moved down 5 units, what is the equation of the new function? Okay, going back to my notes, we can see that a translation is when a transformation shifts the graph of a function either vertically or horizontally, so either up and down or left and right. We know vertical, which is what we're looking at. If we want it to move down, then k is going to be less than 0. Okay, so this k is going to be minus something. Okay, so if we go back to our other problem, all we need to do is subtract 5 to move this down further. Okay, so if we have a positive 3, oh wait, we can't just do that there. We need to change this point, this vertex point, from 2, negative 5 to 2, negative 10. We're moving it down 5 units. So that's our new vertex point. Okay, so now we're going to use our vertex formula, which is y is equal to a times x minus h squared plus k, and we're going to enter the information that we have and then get it back into standard formula so we can figure out what it's going to look like. Okay, so if this is our vertex, this is h and k, so we now have y is equal to a times x, in this case is 2 minus, oh sorry, it's not x, ha ha ha, it's h, I just said that, x minus 2 squared minus 10 is k. Okay, this is our new vertex formula. Now we need to figure out what a is, but we can already look because this is a, b, and c. So a is 2. We don't have to solve for a. We can go y equals 2 times x minus 2. And x minus 2 squared is x minus 2 times x minus 2. So I'm just skipping that step. Minus 10. Let's continue solving. Y is equal to 2 times x is x squared, negative 2x, another negative 2x, a positive 4, and a negative 10. Now we need to distribute this 2 out everywhere, so we have y is equal to 2x squared, 2 times 2 minus 4x, minus 4x, plus 16, minus 10, combine like terms, we have y equals 2x squared minus 8x. That takes care of those two. 16 minus 10 is plus 6, which is none of these answers. Womp, womp. But we know that it should be 2x squared minus 8x, which is all of our answers. And then it should be, we say 6. Guys, how did I screw this up? 1, 2, 3. Oh, you know what? Because I didn't take 0 into account, it's plus 5. My bad, guys, because I can't do basic addition and subtraction. That's why. Here's number 17. Here's number 17. Carolina is traveling away from home. She started 15 miles from home and is heading to a location that is 185 miles away. Carolina is traveling at a rate of 55 miles per hour. Write an equation that represents this scenario and find out how long it will take her to the nearest tenth of an hour to get to her location. So this is a linear problem, obviously. So our formula is going to be y equals mx plus b, where m is the slope and b is the y-intercept, okay? She started 15 miles from home, so that's going to be our y-intercept. That means our b is going to be 15, positive 15, okay? Our slope, to find that, we need 2 points on our graph. I'm a very visual person, this helps me. So we're starting at 15, and we're getting to 185, so clear up here at 185, okay? And her slope is going to be 55, so 55x plus 15 is going to be your formula, okay? 55x plus 15, that's out. Woo! This bottom one is still in. It's this top one that's out, the middle one, okay? So these are our options. Now we need to use this formula and see how long it's going to take her to get to her location. So 15 to 185. So slope formula is, no, we already know slope. How long is this going to take her to reach her destination? So y is her destination, so it's going to be 185 is equal to 55x, because this is going to be time and this is going to be miles, okay? Plus 15, let's get x by itself, subtract 15 from both sides. That's going to leave us, I'm going to have to move over here, that's going to leave us with 170 equals 55x. We're going to divide both sides by 55. And it's calculator time. It's calculator time. We have 170 divided by 50, not 45, 55, gives us 3.09. It wants us to round to the nearest tenth, so it's going to be 3.1 hours. This is our correct answer. Here is number 18. Leah has to write a piecewise function to represent the graph. Which part of the graph should have a domain defined from x is greater than -1 and less than or equal to 0. So let's look at these. Part 1 says x is less than or equal to 1. Okay, nope, and greater than or equal to -3. It's not part 1. You're gone. Part 3 says x is less than 1. Nope. And greater than or equal to 0. Nope. Part 2, x is greater than -1. Okay, that jives. And less than or equal to 0. There we go. It's part 2. Dun-dun! Here's number 19. The function f of x is equal to 3 times 0.75 raised to the power of x represents the decay of a radioactive substance. Create a graph modeling the equation and determine which graph models the situation accurately. Guess what, guys? All we have to do is go to GeoGebra and graph this. Okay, so let's clear everything. Come on, computer. Clear all. Discard. And let's put in our formula. We have f of x is equal to 3 times 0.75 raised to the power of x. Let's look at this and see which one it looks like. Okay, it's going to cross through at 3, which they all do. That didn't help me much. It's going to slope down and level out at about 13, 14, which doesn't help us much. But this is leveling out way too early. And this isn't leveler, so it's going to be option 3. Option 3 is the most logical one there. The graph shows the population growth. What graph? Of a bacteria colony. The x-axis represents the days since measurement began, and the y-axis represents the number of bacteria in the colony. Approximately when did the first bacteria begin multiplying in the colony relative to the day when the measurement began? I just straight up didn't put the graph in. There it is. Okay, so when did the first bacteria begin multiplying in the colony relative to the day when measurement began? So measurement began here, apparently at day 0. So when did the first bacteria begin multiplying? I would guess about day 0, because look, it exists. It's right there. This is how many bacteria. So I would say about, oh, no, it wants to know when it first began multiplying. It actually started before they started measuring. It looks like it started about 2 days before the first measurement. It was here, okay? You could say about 1, but I mean, it's already there. I guess maybe about 1 would be more accurate. About 1 day. I would say about 2. This is a practice, so it's not going to count against your grade. But I would say about 2, because you can see it's starting there. It's well started before day 1. Here's 21. The sum of two numbers is 23, and the product of the same two numbers is 130. Which formula best represents how to determine the two numbers? So when we add two numbers together, we're going to get 23. And when we multiply the two numbers together, we're going to get 130. None of these make sense to me because we only have m as a variable. So which formula best represents how to determine the two numbers? I don't like either of them. I don't like any of these as an answer, and I don't remember this being in any of our lessons either. So a variable times itself plus 23 times the variable minus 130. I really have no clue on this, guys. I'm sorry. I have no clue. They did not teach us this. We did not go over this in any of the lessons. And I have no idea what it wants. So I guess you can Google it and go look. But this makes absolutely no sense to me. We have two separate numbers. Well, I guess one of the numbers could be y. But I mean, none of this just doesn't make sense to me at all. It really doesn't. I'm sorry. I can't help you. They never taught us this. Here's number 22. Which of the following statements is true? The mean is the data's most appropriate measure of center because the data distribution has outliers. So, does this have outliers? Maybe, because it has like 2 up here. Maybe. The median is the data's most appropriate measure of center because the data is symmetrical. Is the data symmetrical? Absolutely not. So, this one's gone. Okay. The mean is the appropriate measure of center because the data distribution is skewed. Is it skewed? Oh yeah, it's got a head here and a tail there. The median is the most appropriate center because the data distribution is skewed. It's definitely skewed. So mean and median, which one is more appropriate for skewed data? Guess what? I don't remember. I'm going to have to go look. Median is your best bet because the mean takes into consideration these and weights them higher than they should. So the median is the most appropriate measure of center. Here's number 23. Estimate the mean and median of the data in the dot plot and then determine which of the following statements is true about the data. So the mean is the mean one that makes you do the math, where you add them all together and then divide by how many dot points you have. And the median is just the one in the center. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 total. So the center is going to be dot number 7, 1, 2, 3, 4, 5, 6, 7. So that means that the median is going to be 7. And the mean is going to be 14, something divided by 14. It's going to be, I can remember this, I swear I can. Yeah, I totally wouldn't have remembered that. I'm so dumb. You have to go 6 plus 6 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 8 plus 8 plus 8 plus 9, 9 plus 10. And then you divide it by, believe how many there are. Okay, that didn't work. Just a second. Oh my goodness, I punched in the wrong number. Oh my gosh, guys, give me just a second. Okay, if I turn my brain on and use it a little bit, the correct answer is adding all of these numbers together. So 6 plus 6 plus 7, 7, 7, 7, okay? And then dividing by 14, the mean is 7.57 some. So looking at this, the mean of the data set is greater than the median. That is correct. The mean of the data set is equal. That is not correct. The median is 8. That is not correct. The mean of the data set is less than the median. That is not correct. I can do this. I'm getting so tired. I really hate algebra. Okay, number 24. Brian calculates the mean and average deviation from the mean for two data sets. Set A, which includes the numbers blah, and set B, which includes the numbers blah. Which statement is true? Guys, I don't remember average deviation at all. Okay, I don't want to do this, but I'm going to force myself to do this. So let's find the mean first for data set A. Okay. The mean is going to be adding all the numbers together. So, I'm recording everything for you. I guess you get to see my calculator. 30 plus 33 plus 42 plus 42 plus 42 plus 51 plus 54 divided by 1, 2, 3, 4, 5, 6, 7. Okay, so our mean is 42 for this one. Okay, so mean is 42, and now we need to find the average deviation. And in order to do this, we take each point and see how far away it is from the mean. So the difference between 30 and 42 is 12. So there's for our first point. The difference between 33 and 42 is 11. Between 42 and 42 is 0, 0, 0. 51 and 42 is 9. 54 and 42 is 12. Okay. Now we need to add all these together and divide by however many we have. So 12 plus 11, I'm going to skip the zeros, plus 9 plus 12 gives us that. Divided by 1, 2, 3, 4, 5, 6, 7. So our average deviation, not standard, right? Average deviation is 6 point, come back calculator, 286, 286. Okay, now let's do all this same garbage for B because you know I care about this so very deeply. Let's find the mean for B. We can grab our calculator. We're going to go 21 plus 29 plus 34, 42, 50, 55, 63. And we're going to divide that by 1, 2, 3, 7. And guess what? That gives us 42 again. So now let's find the difference. 21 to 42 is 11. No, 21. Sorry. 21. 29 to 42. I don't want to try this hard. 42 minus 29, 13. 34 to 42. I'm getting very tired. I don't want to do this anymore. 42, 34, 8. 42, 0, 50 and 42 is 8, 55 and 42 is 13, 63 and 42 is a calculator, it's 21. Okay, let's add all these together and then divide. We've got 21, 13, 8, 8, 13, 21. Divided by 1, 2, 3, 4, 5, 6, 7. So the average deviation here is 12. So let's look and figure this out. For each set, the average deviation from the mean is 42. No, the mean for each set is 42. The average deviation from the mean for set A is 12. Nope. It is for set B. The average deviation from the mean for set A is 6, yeah, but the average deviation from the mean for set B is 12. That would be a correct statement. For each set, the average deviation from the mean is 0. There's your answer. Yay. Number 25. Why is this not over yet? Why is this not over yet? I hate this so much. This is torture. Tilly plays baseball. She tracks the number of home runs hit by her teammates. She also tracks the number of doubles hit by her teammates. The mean number of home runs hit by her teammates is 6 with a deviation of 4. The mean number of doubles hit by her teammates is also 6 with a deviation of 2. Which statement is true? The spread of the data is the same for both data sets. The data set made up of home runs has a greater spread than the data set made up of doubles. The data set made up of doubles has a greater spread than the data set made up of home runs. The spread of data in each data set is impossible to compare. So the deviation is how far away from that standard, that mean it is. So if we have a mean of 6 and a deviation of 4, then it's coming all the way out here to 10 and all the way down here to 2. Okay, this is home runs. If we have a deviation of a mean of 6 and a deviation of 2, then it's coming to 4 and 8. You can see that the doubles is much less spread out than the home runs. The home runs is much more spread out. So the data set made up of home runs has a greater spread than the data set made up of doubles. 26. What is the standard deviation of the data set 10, 13, 11, 16, 21, 15, 25? So now we're doing standard deviation, not average deviation. So it's even harder. Yay! Okay, this is my slide from the lesson on standard deviation with all of the steps on how to calculate it. I did not have this in my notes because I kept writing it on papers and then throwing it away because I'm short-sighted. But, you know, this should be in your notes. I'm going to use this to go back over to the other slides and do this because, you know, we can do this. We have to do this. Okay, let's do all of our steps with this nonsense. So first, we need to take our data value, which we're going to start with 10, and subtract the mean from it. So we need to find our mean first. So let's take all of our numbers and add them together. So we have 10 plus 13 plus 11 plus 16 plus 21, 15, 25, and divide that by 1, 2, 3, 4, 5, 6, 7. So our mean is 15.85. Okay, we're going to call that good. Oh no, 8.6. I apologize. I didn't round appropriately. 8.6. Okay, that's our mean. So what we need to do is we need to go 10. 10 minus 15.86 is going to give us negative 25.86, and then we need to square that. Times 25.86 gives us, oh my goodness. So we're going to have 6 0.68. Come back, calculator. 0.7. I'm just going to go to 1 decimal place because I don't give a crap anymore. Okay. And we need to do that for all of these numbers. Next we have 13. I hate this. 13 minus 15.85 gives us 2.85 times negative 2.85. 2.85 gives us 8.1. Our next one is 8.1. Beautiful. Now we have 11. This is so stupid. I hate algebra. We have 11 minus 15.85 gives us 4.85, negative 4.85 times 4.85 gives us 23.5, 23.5. This is the stupidest thing ever. 16. I'm so done with math. 16 minus 15.85, 86. I'm supposed to be doing this whole time. Oh my gosh. Gives us 0.15 times 0.15 gives us 0.02, 0.02. I don't care about this. I don't care at all. Okay, we have 21 minus 15.86 gives us 5.14. Square that. Gives us 26.4. 26.4. Okay, beautiful. Now we need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 15. That's going to give us 15 minus 15.85 is going to give us negative 0.85. So 0.85 times 0.85 is going to give us 0.7. 0.7. Now we need to do 25. Oh my gosh, now the dogs are barking. Somebody just end this for me. 25 minus 15.86 is going to give us 9.14 times 9.14 gives us 83.5. 83.5. Now the next thing we need to do is add all these together. So, no, come back, calculator. We have 668.7 plus 8.1 plus 23.5 plus 0.02 plus 26.4 plus 0.7 plus 83.5 gives us 810.92, and we're going to divide it by n minus 1, which is 7 minus 1, which is 6. That gives us 135.2, and we're going to take the square root of that, which is 11.6. So the closest is going to be 15.9. So I'm going to say that's the right answer because I don't give a crap. Here's 27. Which of the following data sets has the most variability? Oh, IQR. Heavens to Betsy. I don't remember what IQR is, but I'm assuming it's going to be this one because I think the higher the IQR, the higher the variability. I'm going to go double check that. So this is correct. It's just the highest number because it's subtracting Q3 from Q1. So the more spread out this is, the more variability it has. Here's 28. Compare the box plots summarizing the test scores of students who did complete their homework versus those who did not complete their homework. Which statement is correct? The range in scores for students who did not complete their homework, which is right here, is larger than the range in scores for those who did complete their homework. So they're going from 25 clear up to 85. So 85 minus 25 is going to give us a range of 60. And this is going from 60 to 100, which is only a range of 40. This is a correct statement. Students who did not complete their homework always scored lower than students who completed their homework. That is not correct. The median grade for students who did not complete their homework is the same as the median grade for students who did complete their homework. That's not correct. That's that center line in the box plot. The student with the worst test grade is also a student who did complete the homework. No, that's not correct either. There you go. Yeehaw. Compare histogram 1 and histogram 2. Which statement about these histograms is true? The means, medians, and modes are all different. So mode 3, median 4, mean 5, mean 5, 5, median 6, median 4. Okay, there. So the 5 and 5, they were the same. The means are identical, mean 5, but the modes and medians are not. Mean 4, mean 5, mode 3, mode 7. This is a correct statement. The medians are identical at 4 and 6. Nope. The modes are identical at 3 and 7. Nope. Okay, next one. I got a slide. Number 30, based on the two-way frequency table, which of the following statements is true? The same number of children of each age participate in nap time. So yes, they take naps, 48 and 21. Wrongo. More 4-year-olds participate in nap time, 21, than 3-year-olds, 48. Wrongo. More 3-year-old children nap because their bodies are growing faster. We can't extrapolate like that. More 3-year-old children participate in nap time than 4-year-old children. That is a correct statement. 31. At a community youth bad concert. I like that. Adult attendees were asked if they have a child participating and whether they attended more than one performance of the concert. The results of the survey are in the table, which did not show up. Of the attendees with a child participating, what fraction attended more than one performance? Let me go find that table. So the criteria we're looking at is has a child participating and attended more than one performance. So what our ratio is going to look like is going to be 62 out of 104. So 62 out of 104 is your correct answer. I am so tired. I want this to be over. 32. Distinguish which scatter plot is labeled with the correct relationship. This says no association, positive linear association, negative linear relationship, non-linear relationship. Well, no association. Okay, scatter plot C says this is a negative linear relationship. You can't really draw a straight line through this. It's curved. So this is not correct. Scatter plot D says non-linear relationship. You can draw a straight line through that. That's not correct. B says positive linear relationship. I didn't, but I can draw a straight line through that. That one checks. And scatter plot A, it has a curved line, so that's no association. So that one could also be correct. So I don't know why. It has two that could be right. I don't know why. I don't know why. I don't know why. I guess I would go with this one. I don't know. 33. Michael is training for a 5-kilometer race. The table displays his 5-kilometer running times after the given number of weeks of training. If the slope of the line of best fit is negative 0.82, which interpretation of the slope is accurate? So we know that m is equal to negative 0.82. It told us that. So it tells us Michael runs 1 mile in an average of 0.82 minutes. He's running kilometers, not miles, so goodbye. For every week Michael runs, his time increases by 0.82. Now this is a negative, so it's going to go down. For every week Michael runs, his time decreases by 0.82. Yes. Michael runs 0.82 miles more every week. No, we're dealing with time and weeks, not how many miles. Okay. With more practice shooting basketballs, you can increase your free throw percentage. The data are represented in the table, which I don't have. And the line of best fit is y equals 48 plus 2.1x. Using the line of best fit to find the value for 22 hours of practice and determine whether the line of best fit is underestimating or overestimating. Let me go find the dang table. Okay, here's the table, and the only reason you need to know it is so you can see what's on the x-axis and what's on the y. So time is on the x, and scoring percentage is on the y. Okay, so we have our formula right here, and it wants to know the value for 22 hours of practice, so 22 is going to be our x value. So we're going to go y is equal to 48 plus 2.1 times our x, which is 22 hours. Okay, so let's grab our calculator. We have 2.1 times 22 gives us 46.2. And we're going to add 48 to that. Okay, to find our y coordinate for this. which is going to give us 90 something. I lost it. 94.2. Couldn't remember if it was 94 or 96. 96.2. So for 22 hours of practice using the line of best fit, they say that we should be at X is 22 and Y is 94.2. Let's go back to the graph, to the chart we were looking at, and see what's going on. Our chart says when we're at 22 hours, we should be scoring 95%. The actual percentage that happened was 95%, and what was expected was 94%. So 94.2, and it's the line of best fit is underestimating what actually happened. Okay, so there's your answer there. 35. Determine the reliability of the linear model given this residual plot. Okay, the residual plot is equally and randomly distributed around the line where residual equals 0. That is true. Therefore, the linear regression model is not a good choice. No, we want it to be random. The residual plot is equally and randomly distributed around the line where residual equals 0. Therefore, the linear regression model is a good choice for this data and will provide accurate results when making predictions. It does not have a pattern, so both of these are wrong. Here's number 36. Match the shape of the residual plot to the shape of the scatter plot. How many points must be included in the scatter plot to match the given residual plot? So whatever's here is going to match the other one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's your answer. 37. The trend line for a data set is y equals 5x plus 3.4. One of the actual data points is 5. 37. Find the residual for this point. I don't remember residuals. Okay, this is the y hat crap. So we have an actual data point and we have the trend line. So what we need to do is find, if we have this data point, what they say the y value is going to be. Okay, so let's plug in for x. We're going to say y is equal to 5 times our x is 5 plus 3.4, which is going to be y is equal to 25 plus 3.4, which is going to be y is equal to 28.4. So the actual point is at 37, okay? But the predicted point is 28.4. So now we need to find the difference between these. So residual is y minus y hat, where y is the actual value. The actual value is 37. And y hat is the predicted value, which is 28.4. And I'm busting out my calculator because I am so done with this. 37 minus 28.4 gives us 8.6. So the residual for this is 8.6. Here's 38. Lorraine notices that the cost of repairing a car tends to increase as the age of the car increases. Choose the statement which best explains whether she can infer causation from this correlation. So the name of this lesson is Correlation Does Not Equal Causation. Okay, the answer is always going to be no. And the reason is, in order to connect correlation and causation, you need a true scientific experiment with a lot of control and a lot of repetition, and that just doesn't happen in real life. So because there is a correlation between these two variables, there must also be a causation. No. There is no correlation between the two variables, so there must be a causation. No. There is a correlation between the two variables, and more research is needed to determine if there is also a causation. This is going to be your answer, because it's logical that older vehicles are worth less, but you need to prove it scientifically. Even though there is a correlation between these two variables, there is no causation. No, they probably really are linked, but you haven't proved it. 39, which type of function best models the data in the table? So there's a couple of ways you can solve this. You can look at it and see if you can determine it, or you can go and graph it on GeoGebra. And you know, I've already had one problem that I've had to just be like, I have no clue. I don't know where this problem came from. So let's go to GeoGebra and graph this. Okay, so looking at this, you can see we only have 4 points, and it looks reasonably straight. It might be a little towards exponential, a little bit, and how we can figure this out is let's go to regression. If we come down here, the correlation coefficient is very close to -1, which is a good thing. Let's go quadratic. Plot. And let's look at the coefficient here. It's -0.984. Oh no, this is still linear. Let's look at quadratic. We don't have a correlation coefficient for that. Let's look at growth. 0.99. So it might be growth. It's a little bit higher. So da, 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 da. 0.96 for linear, 1 for quadratic, and 0.99. So I'm guessing this one is going to be quadratic, guys. I would go ahead and put quadratic as the answer for this one. Here's number 40. Use the data to report a bivariate data analysis. The correlation coefficient is R is equal to 0.99. What does the data show about the relationship between temperature and ice cream sales? So if we look at this, this is totally the wrong table. My gosh, I'm doing so well. We're not talking about nap time. Okay, here's our thing. Let's look at it. Temperature's going up. Ice cream sales are going up. Shocker, right? So as temperature increases, ice cream sales decrease? No. As temperature increases, ice cream sales stay the same? No. Temperature and ice cream sales have no association? No. As the temperature increases, so does ice cream sales? Yes. We only have to do this one more time. This was absolute torture, and I'm sorry. I'm suffering too. I've already done this so many times in my life, and I'm doing it again.